Hello and welcome to section 1.2b. We're going to continue on with function and function notation. What I would highly recommend is that you pause here and make sure you get down this stuff, or actually not pause it right here, but I'm going to kind of talk about it, and if you have questions or if you need time to write this down, please pause it and write it down. So this is the summary of all the things that we're going to kind of talk about, what we should have talked about in this section, in section 1.2a and 1.2b. Some of the stuff we haven't talked about yet, but we will today when you come to class. First thing was function is a relationship between two variables. There's an independent variable and a dependent variable. We called it one-to-one. In the last video we defined it as if for every x there's only one y value, and basically we kind of used a vertical line test to help us determine that something was a function by a picture. Function notation, f is the name of the function, so y equals f of x. It could have been y equals g of x, which means g is the name of the function. Y is the dependent variable, or the output, so we end up the g of x is the output that we get, or f of x is the output, and the input then is the x value that we plug into the function. So f of x is the value of the function at x. So basically the y value and the output and the f of x value are the exact same thing. It's what we get when we plug an x value into the function. New things that we haven't talked about are the domain, and the domain of a function is basically where when you plug in an x value, you get a y value. If it isn't in the domain of the function, if you plug in an x value, you'll get something that doesn't work. That'll give you some kind of weird domain error or something like that. It'll tell you that your calculator may tell you, or you may understand that you're taking a number and dividing it by 0. And whenever you divide by 0, it's undefined, and so therefore that would be a domain. That's where our domain falls in. So if I had an equation like y equals x plus 2, the domain is any x value from negative infinity to positive infinity. But if I change the function to something like 1 over x plus 2, you'll notice that when I put in negative 2, the domain, that gives me 0 on the bottom of the fraction, so x cannot equal negative 2, which is a domain restriction. So that is where we'd say it's undefined at negative 2. Range are the output values. What output values are we putting in? I probably should have used f of x for these guys. If f of x equals x plus 2, there are no range. There is no place where the range doesn't work. It's negative infinity to positive infinity, because every x value that I plug in, I'm going to get a different y value, and that y value is only 2 more than the x value, so that I'm not skipping any numbers. But in this equation, the range will be in the second equation, where f of x could be 1 over x plus 2. There will be a range restriction, because there will be some starting and stopping point of the domain at negative 2, so there may be a range restriction by that value. Now this 1 over x plus 2 function, let me rewrite that, this function f of x equals 1 over x plus 2 is basically what we called an implied domain, because we're implying that if I put in negative 2 into this function, then I know the domain doesn't exist there. So these are one of our few functions that we we don't have to say that x can't equal negative 2, because we can see that this is implied that the domain is going to be restricted there. So make sure you get this stuff down. Make sure you copy it down. If you have questions, please come to class prepared to ask them. So then here's the domain of a function. These are both implied domains, because if you notice, if I was to factor the bottom of this function, I would get x plus 2, x minus 2, and then if I put in negative 2 into this function for x, if x is negative 2, then I would get something like 1 over 0 times negative 4, which is still 1 over 0, so that means that it doesn't work. If I tried something like if x was 2, well, I would end up with the same thing, same idea. I'd get 1 over 4, which would, plugging in 2 into the first one, would give me 4, times 0, which still gives me a 1 over 0. So this is our domain restriction, that x cannot equal negative 2, and x cannot equal positive 2. And so these are implied domains, because we can see that from our function, but we may ask you to find them. Then even more implied domain, which I don't know if there's varying degrees of implied domain or not, but in this one is the square root function. So if I'm taking the square root of x, can I put a negative number in for x? Well, and still get a real y value? Well, no, I can't. If I put -1 in, the square root of -1 doesn't truly exist in the real world. So we have to, this domain restriction is basically anything bigger than 0. So x would have to be greater than 0, because if I put 0 in, I can take the square root of 0 and get 0. So if I put f of 0 in, meaning square root of 0, I get 0 for my solution. So x was 0, y was 0. But if I put in 1, I get the square root of 1, which is 1. So if x is 1, y is 1. If I was to plug in -1, there's our problem. Square root of -1 does not exist. So we'll just say DNE. So that's where our domain restriction comes up. And so these are just domains of functions and stuff we're going to talk about. So the domain, remember, is the x value that you plug in. All the x values that work into the function that you plug in. And then finally we have the difference quotient, and we're going to talk about this in class, but I thought I'd give you an example of this. The difference quotient looks like this, and this is something that we use in calculus. Now you're probably wondering what this h value is. It is just another variable. The h value is actually a number that is very close to x, and we're just talking about a slight shift from this. And so now you just have to remember your function notation, so don't panic. If I give you the equation 4x plus 7, well, in this equation, in the difference quotient equation, it's telling me that I'm plugging in x plus h for all x's into this function. And then I'm going to subtract away, plugging in x's into the original function, and all of it's divided by h. So just don't panic on this. It's still the same thing that we've done before. This part right here, this beginning part, is telling me what I'm plugging in for x. So that means I rewrite this equation here. And anywhere I see an x, even if it was an x squared or something, I would plug in x plus h. And so I'd write, there's my first equation. That's this function right here with the x plus h plugged in. Then I'm going to subtract away the whole thing of this second equation, because wherever I see an x in the given equation, I'm going to replace it with x. So basically I'm subtracting the given equation from the one on top. Alright, so now my difference quotient looks like this. And so yeah, it looks like a big mess, but I'm going to do a little distributing and try to make my life a little bit easier. So my next step is to say 4x plus 4h plus 7. There's the first equation with the distributive property done. I'm going to distribute my negative to both sets of parentheses, so I get negative 4x minus 7 all over h. Now you're probably saying, well, wait, what happened here? You lost an h. That should be 4h plus 7. Sorry. And so now, at this point, I can combine like terms and cancel them out. Well, 4x and 4x will cancel each other out, and negative 7 and positive 7 would cancel out. So I'm left with 4h over h, which basically means the h's can cancel out, and occasionally that'll happen, sometimes they won't, but my answer to this equation is 4. Now you may see some relationship between these guys, hopefully you do, but if you don't, we'll practice this a little bit more and you'll start seeing the relationship between these. This quotient, this difference quotient is a big link to calculus, and that's where we're headed in this class, is to calculus. So if you have any questions about this stuff, we will talk more about it in class, but if you have any questions, please come to class prepared to ask them.